In section 5, we're going to look at systems of linear inequalities. So remember, a system just involves two or more things, and this time they're going to be inequalities, like y is less than 2x and y is greater than or equal to negative x plus 3. Our goal with these systems is to find all the points that make both of those inequalities true at the same time. Our goal is to find all points that make both inequalities true at the same time. So for example, is 8, 10 a solution to that original system of inequalities? Well, I'm going to do what we did in the last section. We're just going to plug it in, and this time we just have to make sure it makes both of them true. So when I go to plug in my top inequality, I'm going to get 10 is less than 2 times 8. I'll simplify that in a moment. And the bottom one, I'm going to get 10 is greater than or equal to negative 8 plus 3. Well, that gives me 10 is less than 16, and 10 is greater than or equal to negative 5. 10, yes, is less than 16, so that's good. 10 is greater than or equal to negative 5, yes, so that one's good. It made both inequalities true at the same time, so yes, 8, 10 would be a solution to this system of inequalities. Taking a look at negative 1, 5, plugging in, I get negative 5 is less than 2 times negative 1. Again, I'll simplify in a moment. And negative 5 is greater than or equal to negative 1. That's just positive 1. Why don't I just make that a positive 1? Plus 3. So I get negative 5 is less than negative 2, and negative 5 is greater than or equal to 4. Well, the first one, sure, negative 5 is less than negative 2, so that one's good. The second one, though, isn't true. Negative 5 is not greater than or equal to 4. Both must be true to be a solution, so no, negative 1, negative 5 is not a solution. So we want to graph these systems of inequalities to show all the points that happen to be solutions. What we're going to need to do is first graph and shade the first inequality. Then we're going to graph and shade the second inequality. When I go to graph and shade these, I'm going to use different colored pencils because I think it makes it easier to see which is each inequality. Number 3, then we just want to look for the overlap, the regions that make both inequalities true at the same time. We're going to pick out the overlap and we're going to darken it in. And after I darken in, I also want to outline it using the appropriate types of lines. Part of it might be dashed, part might be solid. I just want to make that very clear. So then we're also going to outline it using the appropriate types of lines. So let's take a look at a couple of these. First, we're going to look at y is less than 2x and y is greater than or equal to negative x plus 3. I'm going to do my first one in red. Less than 2x, so my y-intercept is 0. I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. I'm going to connect the dots. Again, make sure you're always using a ruler for these. And I'm going to use a dashed line because it's just less than, not less than or equal to. Remember that less than means shade below. So I'm going to shade all the points down here. These are all the points that make that first inequality true. Now I'm going to go and do the second one in a second color. I'm going to use blue. Y is greater than or equal to negative x plus 3. I'm going to start at 3. Slope's -1, so down 1 over 1, down 1 over 1, down 1 over 1. I'm going to connect the dots, and this time I'm going to use a solid line. And this was greater than or equal to, so I need to shade above. The solution is all the points in the overlap, so all the points that are red and blue. This isn't really good enough to make it clear to me which one is the solution, so I do need you just to darken it in. First, I'm going to outline my region. I want a dashed line on this boundary, and I want a solid line on this boundary, just tracing over the lines I already had, and then just darken it in. And again, all these points that I'm shading right now, any point that's in this black region would make both of those inequalities true. In letter B, well, before I go to graph this, that second inequality is okay, but the first one in standard form, I want to rewrite in slope-intercept form. So if I have 2x minus y is greater than or equal to -3, subtract 2x from both sides. Negative y is greater than or equal to -2x minus 3. Divide by -1. Of course, remember when you divide by -1, we need to flip our symbols. So y is less than or equal to 2x plus 3. Both of those got divided by -1. I'm going to graph that one red. So I'm starting at 3. Slope is 2, so up 2 over 1. Up 2, I'm out of space, so let me backtrack a little bit. I'm going to go down 2. You know what? Let me try that again. Let me actually go up 2 rather than up 3. Sorry about that. I'm going to go up 2 over 1, up 2 over 1. And I'm still going to try to backtrack a little bit. Down 2, back 1, down 2, back 1. Connect the dots. We're going to use a solid line here. It's less than or equal to, so I'm going to shade below. And again, make sure you shade in the entire grid. That happens to be below that line. Now for the second one, I'm going to start at 1. My slope is -1/2, so down 1 over 2, down 1 over 2, down 1 over 2. I think that's good enough. I'm going to connect them with a ruler. And I'm going to shade above. I'm going to shade above. I think that's okay. And then